name is Jordan Haynes, and today I'll be speaking on physical evidence of climate change. A team of researchers, Shaftel, Jenkins, and Jackson, on a NASA working design last updated earlier this year, carbon dioxide levels in the atmosphere have never been this high. Research from the same group of NASA researchers also stated that since 1950, levels have escalated to nearly 400 parts per million of carbon dioxide in our atmosphere. Before 1950, the levels have stayed below 300 parts per million for all of recorded history. Our future is inevitable. Our changes now that we make are significant, and the changes we're making have the potential to be life-altering. We're all familiar with the term global warming and even climate change, but how familiar are we really with these things? According to the Environmental Protection Agency, or the EPA's, website on glossary terms of climate change, last updated September 9th, 2014, global warming is the recent and ongoing global increase of average temperatures near the surface of the Earth. Climate change is an alteration in typical weather patterns over an extended period of time. Today I want to explain how these things in the climate changes are relevant, how they're measured, and how the effects may have an environmental impact on our future. First, let's talk about why and how carbon dioxide is linked to these changing temperatures. According to the same team of NASA researchers mentioned earlier, the levels of carbon dioxide are higher than ever before. The EPA's website on climate change indicators last updated July 2nd, 2014, the high levels have led to damage of atmospheric layers due to carbon dioxide and the greenhouse effect. When carbon dioxide is released into the atmosphere, it creates a shield allowing heat in, but not out, the heat cama state, which causes rising temperatures in our atmosphere on Earth. The greenhouse effect is also described as, by the EPA's website on indicators, July 2nd, 2014. Also from the EPA's website on indicators, this greenhouse effect and high presence of carbon dioxide in our atmosphere has led to an increased temperature worldwide since the 1970s. In support of the EPA's evidence, the National Climatic Data Center's web article, published January 13, 2013, states, begin quote, 2001 to 2012 is the warmest decade ever recorded. In fact, only one other year has been recorded as this warm in the past 133 years, end quote. Now that we've discussed how carbon dioxide affects our atmosphere, let's move on to how data supporting this is collected and analyzed. Plenty of historical and archaeological data collected and recorded through proxies in paleoclimatology support the theory of rising carbon dioxide levels. The NOAA's website on paleoproxy data, last updated November 25th, 2003, describes what paleoclimatology is. Paleoclimatologists are scientists who study and gather information found in nature regarding climate shifts by evaluating tree rings, ice cores, and other natural materials. This allows them to determine the conditions of a certain time period. The NOAA's previously mentioned website also defines paleoclimatologists as scientists who not only collect this data, but also analyze it, evaluate it, and analyze the carbon dioxide levels in the atmosphere. This is possible because different levels of carbon dioxide produce different atmospheric conditions, which in turn produces different patterns of growth and formation in tree rings, ice cores, sedimentary rock. According to both NASA's team of researchers, Shaftel, Jenkins, and Jackson, of 2014, and the paleoproxy data from the NOAA in 2003, we get an example of a tree ring. If the atmosphere is healthy for a number of years, the tree will grow rings consistently with even width. In unhealthy years, the atmospheric conditions will yield a tree ring with wider width or uneven width between the years. The NOAA's website on paleoclimatology, last updated in 2003, states that visible changes like this make it possible for the paleoclimatologists to use this data collected through proxies to determine past conditions of carbon dioxide in the atmosphere. Now that we've talked about carbon dioxide and how it can affect our atmosphere and lead to climate change, and how this data supporting it is collected and analyzed, let's move on to what this means for our future. Shaftel, Jenkins, and Jackson, the team of researchers from NASA, predicted in early 2014 that increased levels will lead to a continuation of temperature increases. Likewise, according to the EPA's web article on future climate change, published March 4th, 2014, by the year 2100 we'll see significant change in weather patterns due to climate change and increased carbon dioxide in the atmosphere. Because carbon dioxide gets trapped in the atmosphere, the world is changing at an alarming rate. The EPA's article on future climate change from March 4th, 2014, also states that by the year 2100, the average temperature on Earth will have increased by 4 to 11 degrees Fahrenheit due to rising carbon dioxide levels. That increase may not seem like much, but it can cause very significant changes. Rising sea levels, a change in destructive weather patterns like an increase in tornadoes, tsunamis, hurricanes. Also, animal migration and reproductive patterns will change as well. Melting of the ice caps are an outcome of this. Now that we've talked about the effects carbon dioxide can have on the atmosphere, how we collect and analyze the data, and also what it could mean for our future, I'd like to conclude with a few more small bits of information. As I mentioned earlier, our future is inevitable. However, changes occurring now are significant and can potentially be life-altering and drastically alter our way of life. With increasing levels of carbon dioxide in the atmosphere, our world is going to change. Today, I've defined climate change and global warming, discussed how carbon dioxide can change the atmosphere, evidence supporting these changes through paleoclimatology, and the impact it will have on our future. I would like to leave you all with these words from the EPA's web article from March 4th, 2014, and begin quote. These changes will impact our food supply, our water resources, our infrastructure, our ecosystems, and even our own health. End quote. Thank you.